Another thing that the fundamental theorem of calculus will help us with is finding the average value. Let's imagine we have a continuous function f of x on an interval a to b. The average value of the function, that is, the average value of the output of the function, can be calculated by taking 1 over b minus a, integrating from a to b, the function with respect to x. This might not seem like an obvious formula, but it does in fact give us the average value. This integration, remember, is adding up a bunch of little rectangles. And it's adding up infinitely many of such rectangles as we take the limit as n goes to infinity. Each of those rectangles has height of f of x. In other words, each of those rectangles has a height of the output of f of x. That means if I divide by b minus a, the distance from b to a, this will give me the average height of f of x. Let's look at this visually. We take a nice, easy to deal with function like y equals x squared. In fact, let me write this as f of x equals x squared. If I want to find the average value of that function, let's say we want to find the average value between 0 and 2. I can't simply plug in the 0 point and then plug in the 2 point. In other words, I can't simply plug in x equals 0 and x equals 2 and average those two numbers. What I have to do is figure out what each of these heights of the points are, add them all up, and then divide by the distance. In this case, the distance would be 2 because we go from 2 down to 0. Another way to think of this is talking about the area underneath. If you think about what the area underneath does, the area underneath gives us this. Area is a two-dimensional object. If I divide that by the width here, going from 2 to 0, so divide the area underneath the function by 2, then what I've done is I went from a two-dimensional thing, which is our area. Dividing by 2 gives me a one-dimensional thing. So we take the total area and we divide it over 2 units evenly. And what this in effect does is it creates a nice horizontal line, or after I've divided by 2, we get a number. And if I draw that number across here on a horizontal line, then the area underneath the horizontal line will be equal to the blue area. Let me do that in this case. If we would have taken the average area formula of x squared from 0 to 2, we would calculate it. Let's go ahead and calculate it. We want to integrate from 0 to 2 x squared with respect to x, and then that'll give me the area. I take 1 over b minus a. In this case, my larger value is 2. My smaller value is 0. Let's calculate that. We end up with 1/2. And then I have to take the antiderivative of x squared. An antiderivative of x squared is 1/3 x to the third plus any constant. We'll use a constant of 0. Plugging in 0 and then plugging in 2 will give us the actual value. When I plug in 2, I get 1/3 times 2 to the third power. When I plug in 0, I get 0. Calculating all of this, 1/2 times 1/3 times 2 to the third power, that would give me 1.33, or just 4/3. That means the average value of x squared between x equals 0 and x equals 2 should be 4/3. Let's think about what that means visually. What that means is if I take y equals 4/3 and I look at that, let's focus, actually let's call this g of x equals 4/3. And let's focus between 0 and 2. And then let's look at the area underneath. I'm claiming that this purple area should be equal to this blue area. If you calculate it, that should level out. That should even out. The blue area and the purple area should give me the same thing. Hopefully that makes sense to you. That's why we can utilize this formula to find average value of a function. It's the connection between the area underneath of a constant versus area underneath of this object. Once we've seen that once, then it's a matter of just calculating the average value of a function and plugging it into this formula, utilizing the fundamental theorem of calculus to do that. Let's do this example. Find the average value of the given function on the given interval. F of x is equal to x to the third on the interval from 0 to 1. Let's go ahead and compute that using the fundamental theorem of calculus. The fundamental theorem of, the average value function would say take 1 over b minus a, integrate from a to b, my function with respect to x. In my case, because we're on the interval from 0 to 1, the b becomes 1 and the a becomes 0. The f of x is the function, well, f of x is equal to x to the third power. Now I can actually do my integration using the fundamental theorem of calculus, we get 1 over 1 as my coefficient. So 1 is my coefficient. 1/4 x to the 4th. We're integrating from 0 up to 1. So we're going to plug in 1, then plug in 0. If I plug in 1, I get 1 times 1/4 times 1 to the 4th. I'm not going to write 1 to the 4th because 1 to the 4th times anything is just 1. In fact, if you want to leave off that coefficient of 1, you can do that as well. When you plug in 1, you get a 4th. When you plug in 0, you end up with 0. And that means the average value of this function is 1/4. That is the average value from x equals 0 to x equals 1. Hopefully that average value idea makes sense. Let me do another example. In this example, we're finding the average value of g of x equals sine of x over the interval from 0 to pi. This is a pretty straightforward example, so let's just get at it. Our function here is g of x equals sine x from 0 to pi. Average value formula, you can see right there. Now the average value formula uses the f of x notation, but very easily we can switch it over to the g of x notation if we really want. The function is sine of x. That's the function we're going to be integrating. We're going to be integrating from 0 to pi. Therefore, my b is pi, and my a is 0. If you take the antiderivative of sine, you get negative cosine. We've done that enough that we should know that. Notice the coefficient out front is 1 over pi. Because our limits, because the bounds go from 0 to pi, we are going to take from 0 to pi as the bounds. And then I can start plugging in my values. I take 1 over pi multiplied times negative cosine of pi minus 1 over pi times negative cosine of 0. Now I have to be a little bit careful. Remember, cosine of 0 is actually 1. Cosine of pi is actually negative 1. So I'm negating a negative 1. That's going to give me a negative of a negative 1, gives me a positive 1, obviously. So I have 1 over pi, negative of negative 1 minus 1 over pi. The negative of a positive 1. Again, be careful on the negative signs here. When you add these, what you get is you get, oh, that should have been a negative of negative 1. Excuse me. Sorry. So you should get a 1 in here, and this is minus a minus 1. So what you're getting is 1 copy of 1 over pi, and this all becomes another copy of 1 over pi. So 1 over pi plus another copy of 1 over pi. If you're giving an exact answer, it would be 2 over pi. If Moodle asks you to round that to 2 decimal places, you would write 0.64. And there you go. So 0.64 is the average value of sine of x on the interval from 0 to pi. Calculus, therefore, gives us a really nice, efficient way to find average value of a function. I would like you to try this problem. Go ahead, push pause on the video, and find the average value of this function on the given interval.